You might have seen radians before, and you might have even heard that there are 2 pi radians in a circle. But what actually is a radian, and why are there 2 pi of them in a circle? Well, the first thing to know about radians is that, just like degrees, we use them to measure the size of angles. Now, in a previous video, we talked about angles in some detail, but if you haven't seen that video, I'll recommend that you pause this one and watch it now. The link is below. But just to remind you, you remember that whenever we have 2 lines that intersect in a single point, like this, we can look at that point of intersection and, starting from one of the lines, see how far around do we have to go until we reach the other line. And that is the angle between the 2 lines. Now, if the 2 lines are pointing in almost the same direction, then the angle between them is quite small. Whereas if the 2 lines are pointing in quite different directions, then the angle can be quite large. Angles also have a sign, which means that they could be positive or negative. Now, a long time ago, mathematicians agreed amongst themselves that whenever we move in a counterclockwise direction, like we did here, then we say that the angle is positive, and if we move in a clockwise direction, like so, we would say that the angle is negative. So this is positive, this would be a negative angle. But it's important to understand that this is just a convention. It's an arbitrary standard that everyone agreed to follow so that it would be possible for mathematicians to communicate clearly with each other. Now let's move to looking at a circle. Where are the angles on a circle? Well, remember that to get an angle we need 2 lines that meet at a point. So one thing that we can do is take 2 different radii of a circle pointing in different directions, and these radii will then intersect at the most important point of a circle, namely its center, like so. And then we can look at the angle between these 2 different radii. Now, if you look at the edge of the circle out here, you'll notice that these 2 radii determine an arc on the circle, starting at one of these radii and going to the second radii, like so. Of course, if the angle is small, then the length of this arc from one radius to the other is small as well. If the angle is large, then the length of this arc would also be quite large. So an angle at the center of a circle determines an arc on the circumference of the circle. But we can also go backwards. We can take an arc on the circumference of the circle, for example, an arc like this, and we can use it if we line up our 2 radii with the endpoints of this arc, like so. We see that we get an angle at the center of the circle. Okay, so there's a correspondence between angles at the center of the circle and arc lengths around the circumference of the circle. Well, now we're ready to see what a radian is. To do this, we take a piece of string, put one end at the center of the circle, and mark out on the string a length exactly equal to 1 radius. Let's cut the string there. Okay, so now we've got a piece of string that is exactly equal in length to the radius of the circle. Now we just take this piece of string and take it to the edge of the circle and use it to mark out an arc, like so. And this arc has length exactly equal to the radius of the circle. And of course, this arc determines an angle at the center of the circle, like so. From one endpoint of the arc to the other. And in fact, if we like, we can cut this out like so. And so we get an angle that looks like this. And this angle here is exactly 1 radian. This is what it means for an angle to be 1 radian in size. So in other words, a radian is the size of the angle that we get at the center of the circle when we take an arc whose length is equal to the radius of the circle. Okay, so now we know what a radian is. But now we could ask, well, how many radians are there in a circle? Well, let's see. We already have one, so let's just keep going. Here's the second one. Let's cut that one out. Like so. Okay. Another here. Try and be precise. Like so. Okay, so that's 3 so far. Let's keep going to the center. That's 4. 5. Let's see. 6. And a bit left over. Okay, so it looks like there's 6, but a bit left over, and this bit left over, well, it's hard to say, but my guess is it's about roughly about a third of one of those other pieces. So it looks like about 6 1/3 radians in a circle. But let's think about this a bit more and see if we can understand what's going on a bit better and maybe get a more precise answer. Now, as we were working this out, as we were working out how many radians there are in a circle, what we were doing really was working out how many times this piece of string goes into the circumference of the circle. And the answer was about 6 1/3 times. But remember that the length of this piece of string is equal to the radius of the circle that we started with. So really what we're asking here, what we're looking at, is how many times does the radius of the circle divide into the circumference of the same circle? Well, if you think back to the previous video, this is exactly what we saw in that video. And there we saw that for any circle, the circumference and the radius of the circle are related by the formula c equals 2 pi r, where here c is the circumference, the distance around the outside of the circle, and r is the radius of the circle. And if we rearrange this, we get c divided by r is equal to 2 pi. And in fact, you remember from the previous video that this is actually the definition of the number pi. But let's look at this formula. On this side, we've got the circumference divided by the radius, or in other words, how many times does the radius go into the circumference? And this is exactly what we were just working out with this piece of string. And on this side, we see that the answer is 2 pi. Well, we know that pi is approximately 3.14, so 2 pi is approximately 6.28, which is pretty close to 2/3, to 6 2/3. And so this all matches up very nicely. And now we have a precise answer to our question, which is that there are exactly 2 pi radians in any circle. Now just take a second to stop and think here. Did I actually measure the length of the radius here with a ruler? No, I didn't. I could have used a circle of any size, of any radius, 10 centimeters, 100 meters, or a fraction of a millimeter. Nothing that I've done so far depends on the size of the circle that I use. As long as I use a piece of string whose length is equal to the radius of the circle that I'm working with, everything will be exactly the same as what we've just seen here. And that means that there are always 2 pi radians in any circle.